Download this code from codegive.com, link in the description below. Better design with custom messaging abstractions for CQRS. In the command query responsibility segregation, CQRS, pattern, we separate the read and write operations into different models. This separation allows us to optimize each model for its specific task and improve the overall maintainability and scalability of the application. Custom messaging abstractions can enhance communication between different parts of the system, making it easier to implement CQRS effectively. In this tutorial, we will create a simple example of how to implement custom messaging abstractions in a CQRS architecture using C. We will focus on building a command handler and a query handler using custom messages. Prerequisites: basic understanding of CQRS principles. Familiarity with C and .NET development. Step 1. Define custom message types. We'll start by defining custom message types for commands and queries. This will help us encapsulate the data that needs to be passed around. / command message. Public abstract class command. Public GUID ID get, private set. Public datetime created at get, private set. Protected command. ID equals GUID.new GUID. Created at equals datetime.utc now. / query message. Public abstract class query tResult. Public GUID ID get, private set. Protected query. ID equals GUID.new GUID. Step 2. Create specific commands and queries. Next, we will create specific command and query messages. For this example, let's assume we are working with a simple task management system. / create task command. Public class create task command, command. Public string title get. Public string description get. Public create task command, string title, string description. Title equals title. Description equals description. / get task query. Public class get task query, query task. Public GUID task ID get. Public get task query, GUID task ID. Task ID equals task ID. Step 3, implement command and query handlers. Now, we'll implement handlers for our commands and queries. The handlers will be responsible for processing the custom messages and performing the required actions. / task entity. Public class task. Public GUID ID get, private set. Public string title get, private set. Public string description get, private set. Public task, string title, string description. ID equals GUID.new GUID. Title equals title. Description equals description. / in-memory storage. Public class task repository. Private read-only list task _ tasks equals new. Public void add, task equals _ tasks.add, task. Public task get by ID, GUID ID, equals _ tasks.first or default, t equals t.id equals ID. / command handler. Public class create task command handler. Private read-only task repository _ repository. Public create task command handler, task repository repository. _ repository equals repository. Public void handle, create task command command. var task equals new task, command.title, command.description. _ repository.add, task. / query handler. Public class getTaskQueryHandler. Private read-only task repository _ repository. Public getTaskQueryHandler, task repository repository. _ repository equals repository. Public task handle, getTaskQuery query. Return _ repository .get by ID, query.task ID. Step 4, putting it all together. Now we can create instances of our command and query handlers and use them to perform operations. Sharp. Public class program. Public static void main, string args. var repository equals new task repository. var command handler equals new create task command handler, repository. var query handler equals new get task query handler, repository. / create a new task. var create task command equals new create task command, learn CQRS, study the principles of CQRS. Command handler.handle, create task command. / retrieve the task. var task equals repository.get by ID, create task command.id. console.readAlign, $task title, task.title, description, task.description. Conclusion. In this tutorial, we demonstrated how to implement custom messaging abstractions in a CQRS architecture. We defined message types for commands and queries, created specific command and query classes, and implemented handlers that process these messages. This design allows for better separation of concerns, which is essential in CQRS, and makes the codebase easier to maintain and extend. You can further enhance this design by incorporating features such as asynchronous processing, event sourcing, and integrating with messaging frameworks like RabbitMQ or Azure Service Bus for distributed systems. Feel free to adapt and expand upon this example to fit your own CQRS implementations.